Dear students, we are starting with the EOT review, grade 11 advanced term 3 2026. See, as you can see, we are going through chapter wise. Like in each chapter, there are certain questions which is mentioned. In the first chapter, we have 5 questions which is specified. Now, let me say, according to the learning objective, there are 3 main concepts which is stretching in the first chapter: angular displacement, angular velocity, and angular acceleration. And along with that, this is in rotation. Along with that, this will be connected in a linear motion, straight line motion. Okay. Another important concept, there is a conversion between degree and radian. And this is happening in the first lesson. Its chapter is easy. So first and foremost, what we are going to do, we will be explaining the concept a bit and then we'll practice few questions. Okay, this is the plan which we have. Let us start with the first concept. See, according to the learning objective, define radian and convert degree to radian, vice versa. That is the first concept which is dealing with. First, let us understand, think of it. If an object rotate in a circular track, obviously it will be rotating an angle, right? And this angle rotated by the object, we call it as theta. Okay, theta will be nothing, it's the angle rotated by the object, or we call it as angular displacement. Now, how this angular displacement is connected with the radian? So far we measured this angle in degree, but hereafter we will be measuring the angle in radian. So how do we measure angle and how they are related with the arc length and radius? See, radian is nothing. Radian is the ratio of arc length to the radius. Okay. Suppose if I just need to measure 1 radian. So what I need to do, I will take an arc length, for example. Like if the radius of this particular circle, let me say it's 1 meter, then the arc length, if I am considering it as 1 meter, so obviously they will be measuring an angle, right? This particular angle will be considered as 1 radian. So what is 1 rad? 1 rad is nothing. When the arc length is equal to the radius, the angle subtended by or angle produced by the arc length at the center, we call it as 1 radian. Okay, this is the radian idea. Now you know that if I am using another color, look at, see, if this is a straight line, the straight angle is actually how much? Straight angle is 180 degree. And if you measure this particular arc length, see, that arc length will be equivalent to 3.14 meter, or if this is like 1 meter radius, then this will be 3.14 meter. So when you convert this 180 degree, that 180 degree will be equivalent to 3.14 rad. We normally write it as pi. Pi is nothing, it's 3.14 rad. Okay, so this is how we will be connecting degree and radian. See, 180 degree always will be equal to pi radian. Okay, rad is nothing, it's radian. Now, the first question, they are asking you to convert radian to degree and degree to radian. To convert degree to radian, as you see, like degree in radian will be equal to angle in degree multiplied by 180. So if you multiply the given angle with pi by 180, then you can convert that into rad. I'll take an example and explain. Okay, suppose an object rotates 30 degree and you need to convert this angle into radian. So how do you do? This 30 you should multiply with pi by 180. Okay, and you put the calculator, you will get a number. So obviously over here you will be getting pi divided by 6. Fine, pi divided by 6 radian. Now let us look at the next one. Look at, see over here, the degree, you should convert radian to degree. Okay, to get radian to degree, you will do exactly opposite. Let me use another color. See, for example, let me say I have an angle like pi by 4 rad. This pi by 4 radian I need to convert into degree. What I'll do? I will multiply pi by 4 with 180 divided by pi. Okay, pi and pi will get cancelled. Finally, you will get an angle 45 degree. So this is just an example to make you understand. Now, along with this particular learning objective, they have given one more information. Identify that the counterclockwise motion is positive and the clockwise motion is negative. Look at. See, whenever you look at a circular motion, it can rotate in two different directions. One is clockwise motion. This is the clockwise motion. And second one is counterclockwise motion. Okay, so all the counterclockwise motion will be considered as positive angle, and all the clockwise measurement or motion will be considered as negative angle. Okay, so I'll just take the next slide so that it will be a little clear to you. As we mentioned, like, see, look at, this is which direction? Counterclockwise. So the measurement will be positive. And this is clockwise. The measurement of the angle will be considered as negative. Okay. So this is positive measurement and negative measurement. So this is all about the first learning objective and the first concept. Now let us move to the second concept, the next concept. The next concept, we are connecting arc length. We are connecting arc length, means the linear distance, and the angular displacement, which means the angle rotated, and the radius of the rotating object. Okay, so over here I have a disk. Okay, see, this disk rotated an angle theta. So linearly, for example, if this is the point A, how much linearly this point A will be moving, and that distance we call it as x. So this is the relation x that will be equal to r theta. So what is x? X is nothing. X is the linear distance traveled by the rotating object, and always linear distance we will be measuring in meter. And what about the r? It's radius. Obviously it will be measured in meter. And what about theta? Theta will be measured in radian. Okay, this is how one important thing you need to remember. Sometimes to make you confuse, in a question they will give degree. For example, in this question I'll take, like, over here the radius of this circular track, let me take it as 2 meter, and the angle rotated is 30 degree. And if I'm asking you to calculate x, how do you do? Generally, like, we make a calculation in such a way that x will be equal to r theta. I need to calculate x. So what I do, I put the value of r as 2 and r as 2 meter, and like x as 30. Okay, so what I'll get 60. But do remember, this is wrong. Why? Whenever you do the calculation related with the x is equal to r theta, the angle must be measured in radian, which means first of all you need to convert this particular angle into radian. So how do you do that conversion? You know, the given angle must be multiplied with pi divided by 180, so that you will get the angle pi by 6. Means this is in radian. Okay, this is in radian. Once the angle which is in radian, then you have to calculate x, that is equal to r theta. How do you do? X, r, we know that is 2, and then theta is pi divided by 6. So you can cancel it, and finally you will get pi by 3. So over here, how much meter the particular object or A will be moving? So it will be pi by 3 meter, which means 3.14 divided by 3. So approximately 1 meter something it will be moving. Okay, this is just for your understanding. Now let us go to the next concept which is coming from the lesson. Okay, this is angular velocity. Okay, so what is angular velocity? Angular velocity is the angle rotated by the rotating object in 1 second. If an object is rotating in a circular motion, so in 1 second, how much angle it will be rotated? And there is an equation to calculate it. See, angular velocity will be represented with omega. This is a Greek letter omega, and it's look like a W. Okay, the small letter W. So this W is nothing. It's angular velocity. Okay, angular velocity or angular speed, and it can be measured by using change in the angular displacement. What is theta? Angular displacement divided by the time taken. Okay, angular displacement by time taken. Now, let me take an example. Like, see this particular concept or this particular angular velocity, we can calculate another way as well. Means using another equation. Let me write that equation over here. Omega will be equal to 2 pi f. So how do we get this equation? That is another important information. Look at, think of it. This is a car, and the car take t second to complete one rotation. So what is t? By now, or you might have learned before, t is period. What is period? Period is nothing. It's the time required to complete one rotation. So over here, the time taken by the car is t, period. So in one rotation, how much angle it will be rotated? Delta theta. The theta rotated over here, it must be in one rotation, you know, it will be 360 degree. So if it is 360 degree, how much that will be in radian? So you have to multiply this with the pi divided by 180. So you will get it as 2 pi. So always do remember that in one rotation, the angle rotated will be exactly equal to 2 pi radian. Okay. Why do we do this? See, to make you understand, like suppose in this particular situation, if I need to calculate the angular velocity, so which is the equation? Omega will be equal to delta theta by t. Okay. So what is delta theta over here? Look at delta theta for complete rotation, it is 2 pi. And what is the time taken? By t. And you already aware of, like, what is frequency? Frequency is 1 over time. So this 1 over time, I can rewrite in such a way that 2 pi f. So we have another equation to calculate omega. Omega is equal to 2 pi f. Okay, this is an important information we needed. Along with this information, you need to remember one more. Like, see, what is the unit of omega? You know that the angle right now, we will not be measuring in degree, we will be measuring in rad. So the unit of delta theta will be rad. Okay, and you know the unit of time, that will be in second. So what is the unit of omega? The unit of omega or unit of angular velocity will be rad per second. Okay, so these are the information you need to remember in connection with the third concept. Okay, now let us look at the next. See, the next learning objective is connected with the angular velocity and linear velocity connection. As you can see in the figure, see, a car is using a tire. Obviously, the tire will be rotating, right? So it will be having omega. So if a car is rotating in a circular manner, the car is moving in a linear direction, in a straight line motion, right? So how much speed the car will be moving if the car is rotating with an angular velocity of omega? So this is the relation. So the linear velocity that you can see in the car, like a speedometer, that linear distance v, that is equal to r omega. Okay. So what is r over here? R is nothing, the radius. And what is omega? Omega is angular velocity. Okay. So I'll take an example. suppose you are in a car and moving at 60 km per hour. Okay, and if you know the radius of the car tire is around like 0.5 meter. Okay, then what you can do, you can just use this information to calculate the angular velocity. But do remember that whenever you do the calculation, convert kilometer per hour into meter per second. Then do the calculation. So what it would be? So over here, the omega linear velocity is divided by radius. So omega I can calculate by using V divided by R. So what is V? V is 60. Okay, I need to convert that into like meter per second. It's 1 kilometer, 1000 meter will be 1 kilometer, and 1 hour will be 3600 meter. Okay, whole divided by the radius will be 0.5. Put it in the calculator, you will get a number that will be the angle rotated by that particular car in 1 second. Okay, this is just for your information. Okay, this is the third concept, and this concept is also somewhat very easy. Okay, but along with this, another important information which is to be connected. See, suppose if this is a rotating object, if I consider 2 points, one is closer to the center, another one is farther away. Let me say the point A and point B. Suppose if the car tire is rotating, the point A and point B will be covering exactly the same angle, but they will not be covering the same linear distance. Okay, so think of like the car is just rotating, the car tire is rotating. So after some time, this particular radius has reached over here, which means the point A will be right now. Let me mark it as A dash, and point B will be right over here, B dash. See, suppose if I am like looking at two information, one is V, another one is omega. Let me say the angle rotated by the A and the angle rotated by the B will be exactly same. There is no difference. Okay, so what I can say, the point A, the angular velocity of point A must be equal to angular velocity of point B. There won't be any different. Okay, but what about the linear distance covered by the point A and point B? See, the linear distance covered by the point A will be smaller, and the linear distance covered by the point B will be larger. So in this particular situation, do remember, like the velocity, the linear velocity at point A must be smaller than the linear velocity at point B. Okay, so this concept is very important. They can connect this concept in an MCQ. Fine. Now let us go to the next topic and concept. The next concept is connected with the direction. Okay, even it's not specified in the learning objective, but still you need to remember. Okay, suppose you have a toy car and you are rotating that toy car in the floor, okay, in a clockwise or a counterclockwise direction. So whenever it is rotating in a circular track, it will be having a velocity direction. So what will be the direction of velocity? It will be perpendicular to the surface of rotation. So if it is rotating on a floor, then the angular velocity direction will be perpendicular to the surface of rotation. I'm repeatedly saying the angular velocity direction will be perpendicular to the surface of rotation. Over here you can see this is a car which is rotating in a plane, and the angular velocity is exactly perpendicular to that. And to find the direction, see, you can use your right hand, or in the right hand the forefinger you will hold in the direction of rotation, and the thumb will give the direction of the angular velocity. So if it is rotating in counterclockwise, okay, counterclockwise, so then the direction of angular velocity will be upward. If it is rotating in clockwise, this is a clockwise motion, so if it is clockwise, then it will be down. Okay, and again I'm going to the the rule. To find the direction of angular velocity, you have to hold your forefinger in the direction of rotation, and the thumb will give the direction of the angular velocity. Okay, so the easy way, counterclockwise upward. and clockwise downward. Okay, that is the easy way to remember. Now let us go to the last concept. See, this is the fifth concept. We call it as angular acceleration. Angular acceleration, as you can read over here, it's a change in angular velocity divided by time taken. See, angular acceleration will be represented with a letter called alpha and can be written as follow. Okay, so over here, this is the equation you can look at. Alpha is equal to delta W divided by delta T. And as you see in the figure, acceleration increasing the speed or slowing down. Now, so how do we calculate? Using this equation, alpha, that is equal to delta W divided by delta T. Now, what is this W? You already know that it's angular velocity. Okay, this is angular velocity. And what is T? You know, it's time taken. Time taken. Now, how do you find the change in angular velocity? Change in angular velocity will be omega final minus omega initial, or W final minus W initial, divided by delta T. Delta T is also T final minus T initial. So this is how we will be finding the change. Now, look at angular acceleration will be measured with a unit. See, you know, angular velocity will be rad per second, and denominator we have what, a time, so divided by time. See, the two time or seconds is coming together, we can call it as a rad per second square. Okay, so angular acceleration will be measured in rad per second square. Fine. See, learn to use the table of the equation table to use the appropriate equation. Okay, this is very much needed. So the problem, majority of the student, they read the question, they do not know which equation they will be using. So to overcome that, like whenever you practice by using this particular table so that it will be much easier in the examination. Okay, now let us just start with the first question. See, a glass door is rotating. Think of it, we have a glass door and that glass door is opening. Which direction? Counterclockwise direction it's opening. Okay, and what is the angle which is rotated? It's 60 degree. Now a student pushes it with the following. Currently represent a rotation in a radian and direction. Like, see, the student apply a force, and as it is rotating, and it is rotated at an angle of 60 degree, and what they demand, this you need to convert into radian, and you have to choose the appropriate answer. So it's easy question, I believe. So you know, like, how do you convert degree to radian? You need to multiply that with pi divided by 180. Okay, so just multiply pi by 180. So what you will get? 60 by 180, 60 and 180, when you cancel, it will be pi divided by 3. So if it is pi by 3, you can cancel pi by this two option. It's not there. Okay, it's not correct. Now we have two option which is connected with the pi by 3. One is minus pi by 3 rad clockwise and the pi by 3 rad counterclockwise. As it mentioned counterclockwise, so which one it would be? It will be B. Okay. Now let us look at the next question. See, a robot, arm rotated. We have a robot and which is rotating its arm. Okay, how much angle it is rotated? It's rotated an angle of minus 2.1 radian. Okay, see, be conscious of this particular question. They mention negative. So from the negative sign, you should understand the sign will be, or the direction of rotation will be clockwise. Negative sign, clockwise. Okay. Now, while adjusting its position, which statement best describes this motion? So how do we get it? Look at the arm rotated clockwise. See, counterclockwise. See, this is wrong because we know that it's clockwise because negative is mentioned. So the option A and C you can easily remove. So only two options which is connected with which one, clockwise. Let us just check. See, the arm rotated 2.1 rad clockwise. Yes, correct. This is the correct answer. Okay, and let us check whether this answer is also correct. How do you do? See, over here they have specified it's 2.1 radian and this is in degree. So first of all you need to convert it. How do you convert? To convert radian to degree, you will be just multiplying this with 180 over pi. So 180 over pi, when you do, finally what we will get, it will be 120. Okay, so 120 degree. So 120 degree clockwise, this is also correct. So this particular question we have two correct answer. One is B and another one is D. Okay, now let us go to the next question. A driver turns the steering wheel 45 degree clockwise. Make the slight turn. And what is the equivalent angular displacement? So you need angular displacement in radian. Okay, so all the options they have given in radian. But look at some options they have negative, some option they do not have. Okay, so before converting, how do you eliminate the option? Look at it's clockwise. We know clockwise is what? Negative. If negative, then I can remove this option as well as this option. Now to select the correct option, what I need to do, I need to convert it. It's easy again. 45 must be multiplied with a pi over 180. Why pi over 180? Because you need to convert degree to radian. So as you convert, you will get pi divided by 4. So which option will be correct? Negative pi over 4 rad. Okay. So practice, there will be more question which will be uploaded in the PDF. Okay, so you can practice it. Now let us just go to the next question which came before. See, a bike wheel rotate 4.5 revolution. They haven't said in no degree, nothing they have given. And how many radian? So you need to see the answer in radian. But do you think they have given in degree? No, nothing. They just said the number of revolution. So this is what you need to remember. In one revolution will be equivalent to 360 degree. That will be equivalent to 2 pi. We know these we converted at the beginning. Okay. So one revolution will be 360 degree. That will be 2 pi radian. Okay. So how many revolution we have? We have 4.50 revolution. So what is to be done? You need to just multiply this angle with the 360, or like anyway they are asking in radian. So 4.5 multiplied with 2 pi, that will be the answer. How much it will be? 28.3 rad. Okay. Now let us go to the next question. See, this is how, or this is from where we need to use our formula sheet. Of course, in the question or in the exam, they will be giving this formula sheet in a different form, but you need to select after reading, like which equation am I supposed to use? Okay, so let us read the first question. How many degree correspond to 1 radian? So I need to convert 1 radian to degree. Easy. You know it. What is 1 radian? How do I convert it? Radian to degree? 1 multiplied by 180 over pi. So how much it would be? It will be 57.3. So which will be the correct option? This one. Okay. Now let us look at the next question. See, it's not connected with the first question, like it's connected with the second question in the Haikal. The length of the path. Length of the path. What is length of the path? We call it as arc length. Normally we represent with the x, right? AB shown in the figure is equal to 73.4 centimeter. Okay, and the radius of the circular track is given 0.56 meter. Okay, this is the question, and what they ask, what is the value of angle in the figure? So you need to calculate theta. So there are three parameters which connecting x, r and theta. Look at the equation list. Which question or which equation will be connected with it? X, r and theta, this will be connected off, right? So what do? You will be connecting x is equal to r theta. X value is given in 73.4 centimeter. You should remember in such a way that whenever they give centimeter, convert into meter. To convert meter, you will divide this with 100. So it will be 0.734 meter. Okay. So x value they have given, it will be 0.734 and r value is given 0.5 meter and theta you do not know. So you can do one thing, you can shift and solve, you can get the answer, or you can just bring to this to the other side. Okay, divide this with 0.5 and this also with 0.5. So you will get an answer around 1.31. Okay, so this is how we do. Fine. Let us continue. So this is a question in connection with the earth rotation and the rotation angle. So it is known that the earth rotates about its axis. You know that. What angle does the earth rotate through 8 hours as viewed from above the south pole? Okay. So let us look at this situation. See over here, this is north pole and this is south pole. Suppose if you are standing over here and looking at the earth, you can see earth is rotating in which direction? Earth is in counterclockwise direction. But suppose if you stand over here and then look at, then you feel it like earth is rotating in which direction? Clockwise direction. So on top of the north pole you will feel it like counterclockwise. On top of the south pole, when you look at, you will see it as like as you can understand, this is rotating in this way, right? So if you stand and on top of the south pole, you will feel it like clockwise. So over here on top of the south pole you will feel it like a clockwise, and over here on top of the north pole you will feel it like a counterclockwise. Okay, counterclockwise. So as we said, see, we the question demand like south pole. Obviously you can eliminate this two option. This is wrong as well as this is wrong. Why? See, counterclockwise positive, that option you can eliminate. Only two options we have. Now what is to be done? Like, see, they're asking in 8 hours how much angle will be rotated. Okay, so for that you need to understand, or we need to know that, like, see, earth will take 24 hours for one rotation. Okay, 24 hours for one rotation. Okay, now let us connect this with the hours with the angle. Okay, so in 24 hours, how much angle it will be rotated? It will be rotated 2 pi. Fine. So how do we calculate the angle rotated in 1 hour? It's easy, right? So what we do? The total angle rotated by the total time taken. So this will be the angle rotated in 1 hour. Angle rotated in 1 hour. Okay, 1 hour. Now see what they are asking. The question demand angle rotated in 8 hours. So what is to be done? If this is the angle rotated in 1 hour, you just need to multiply this with 8 so that you will be getting 8 hours. So angle rotated in 8 hours will be equal to angle rotated in 1 hour, 2 pi divided by 24 multiplied by 8. Okay, so what you can do, you can just cancel it, it will be 3. So you will be getting 2 pi divided by 3. See, 2 pi by 3, like anyway the positive option we have eliminated. So which is the correct answer? The correct answer is the first one. Okay, 2 pi by 3, and why there is negative? The negative sign indicate, like on top of the south pole you will be seeing it as clockwise, so obviously what it would be, it will be negative. Okay, now let us move to the next question. Yeah, let us continue. See, this is in connection with the second question. We know the relation, like x that is equal to r theta. Okay, so over here in this situation, look at, a children stand on a merry-go-round of radius is given, it's r, 2 meter. The platform rotates so the child travel an arc length of 3.5 4 meter. Okay, so what is this arc length? You should understand arc length, which is mentioned in meter, that is x. Then what they need? They need angular acceleration, sorry, angular displacement. So what is angular displacement? Angular displacement is theta. Look at x, r and theta. So which will be the equation? Yeah, you know that it will be x is equal to r theta. So you know x is equal to r theta. X value is given 3.14 and r will be 2 and then theta. Okay, so you can do shift solve or like do the normal way. So what you will get around 1.57. Okay, so which one will be? A will be the correct answer. Fine. Now let us go to the next question. In this question, a car tire radius is given. So no, this will be the radius. Rotate and point on a thread moves through an arc length of 1.57 meter. Okay, so again the same idea, x is given and r is given, and then what they need? Angular displacement they need. Okay, so I think it's easy. The same way you can calculate x is equal to r theta. Okay, x over here right now it is 1.57 meter and r is 0.25 and theta you can calculate it. Okay, so you can shift solve again, like, or you can do one thing, you can just divide 1.57 divided by 0.25. okay, that will be equal to theta. So over here what value you will get? 1.57 divided by 0.25. okay, so it will be 6.28. so we have B as the correct answer, 6.28. Now again another question which is connected with a car tire of radius 0.2 meter. Again, what is this? This is clearly mentioned radius. Rotate 2 revolution. What is the distance moved by a point on the thread? See, look at, suppose this is a point. Okay, so after 2 rotation, linearly how much distance it has been moved? That is a question, which means you need to calculate x and they have given radius. But do we have theta over here? Of course they have given, instead of theta they have given 2 revolution. We know that 1 revolution is 2 pi. So 2 revolution, the theta will be 2 into 2 pi. How much it will be? It will be 4 pi. Why? In 1 revolution we know the object will be rotating an angle of 2 pi. So 2 rotation, 2 into 2 pi will become 4 pi. So we have theta and r, then obviously it will be easy. Like which one it would be? Like the equation x will be equal to r into theta. So r will become 0.25 again multiplied by 4 pi. Okay. So finally what we will get pi. Okay. So what is pi? Pi is 3.14. So this will be the fine. Now let us go to the next question. Question is also connected with the second question. Okay, the minute hand of a clock is 0.15 meter long. So which is the minute hand? This is the minute hand. The length is given. Length over here you should understand, length is what? Length will be the radius. The radius they have given directly, like it will be 0.15. Fine. It rotate through a 60.019 degree. Okay, so they have given the angle theta, they have given how much it is? 60.19. okay, what is the arc length? So if it is rotating this much angle, like how much linear distance or arc length it will be rotated? So you need to calculate x. So what is x? X will be equal to r theta. So r is given, it's 0.15. And what about theta? Theta is not given. Theta is not given. Like theta is given, but it's given in the degree. This is what I said before. Like whenever you do a calculation, always the angle must be in radian. So first and foremost, what is to be done? You need to convert this quantity into radian. So when you convert into radian, you will multiply 60.19 into pi over 180. Okay, so when you do this, like, you will be getting approximately 1.05. Okay, so when you multiply it together, you'll get a number 0.1575. So which one will be? B will be the correct answer. Okay, so do remember, this is an important information. Whenever we have a calculation, that calculation must containing like radian, not degree. Okay, now let us go to the next question. This is not in connection with the second question, like this is in connection with the third and fourth. Okay, the figures show a rotating disk. This is a rotating disk. Okay, two spot A and B have been marked. Okay, so which is A? This is A, far from the center. This is the axis of rotation. Through this will be rotating. Okay, and disk sender B is Y. Okay, they marked A is at X, this is X, and Y is at B, okay, which is near to the center. From the disk center, how can the angular velocity of these two spot compare? Angular velocity you need to compare. Fine, the angular velocity of spot A will be greater than spot B. Think of it, if this particular disk rotated about this angle, okay, so like the point Y will be reaching over here and point X will be reaching over here. What is to be noted? The angle rotated by the each point will be exactly same, which means their angular velocity of A must be equal to angular velocity of B. Okay, suppose if I am asking for the linear velocity VA and VB, okay, so who will be rotating? VB means B is closer, which will be rotating less distance. Look at this distance is comparably less and this distance is more. So the linear velocity VA will be VA will be bigger and VB will be smaller. Okay, now look at, read the question, read the option. The angular velocity of spot A will be bigger than spot B. Okay, it's not. Angular velocity is exactly same, so this is wrong. The angular velocity of both spot will be equal. Okay, so this is same, and you can just read the remaining to get an idea how they connected with each other. Now let us move to the next slide. See, next slide is in connection with the question number 3. You know, question number 3 is connected with the angular velocity. Angular velocity will be calculated by using an equation, delta theta divided by delta t. See, so which is the equation for angular velocity? Angular omega will be equal to theta delta theta by t. Now, let us look at a question. The first question, a pottery wheel spin with an average angular velocity of 2.5 rad. What is this? This is angular velocity. They have given omega. Okay, what angular displacement does it complete in 10 seconds? In 10 seconds, how much angle rotation will be completed? Okay, so how do we calculate? What they have not given? T they have given, W they have given, which they have not given, delta theta they haven't given. So you need to calculate it. I think it's easy. So we have the equation, omega is given, T is given. Obviously, which equation we will be selecting? Okay, look at omega and T, and we need theta. So which is connected to omega? Like this is the equation, omega, delta theta and T. So I can write omega will be equal to delta theta divided by T. So substitute the value, omega will be 2.5 will be equal to, what is delta theta? We do not know. You can put x divided by T. T is 10. So what you can just shift solve, you will get the answer. This will be 25, or you can just rewrite, multiply this with the 10 and this also with the 10, so you will get the answer. Okay, now let us go to the next question. Mary go around rotate through 15 rad in 10 seconds. What is 15 rad? Look at, by looking at this particular term, you should understand they have given this is theta, and no one will make mistake about this one. It's t. Okay, theta and t they have given. Now, what is the average angular velocity? Average angular velocity, what is that? Omega. Okay, so how do you calculate this three to quantity connected? Like, it's easy, right? So what it would be? Omega will be equal to delta theta, theta by t. Okay, so theta is given 15 and it's 10. So what it would be? It will be 1.5 rad per second. Okay, so which one would be? C will be the correct answer. Now, this is a textbook question, like which is mentioned in the hyper. Okay, now a rotating toy above a crib make one complete counterclockwise rotation in 1 minute. Okay, so this we have done before. Like, see, you need to connect the angle theta. They have given how much the angle theta is 2 pi. It's not directly given, but from the question you should understand it. Complete one rotation means 2 pi in 1 minute. Okay, so in 1 minute it will be completing one rotation. See, what is the first question? What is the toy's angular displacement in 3 minutes? You need to calculate theta in 3 minutes. In 1 minute, see, look at this is in 1 minute. Okay, so in 3 minutes, how much it will be? It's easy, I think. Like, see, in 1 minute, one rotation, 2 minutes, two rotation, 3 minutes, three rotation. So 3 rotation, 3 into 2 pi will become how much? 6 pi. Okay, so which one will be the correct answer? 6 pi radian. Now, what is their toys angular velocity? Okay, angular velocity they asked you to calculate in rad per minute. Okay, it's in rad per minute. So we know angular velocity will be calculated theta divided by t. Theta will be what? Theta will be equal to 6 pi, and how many time it will be taking? How much time it will be taking? It's 3 minutes. Okay, so you can just cancel. Finally, you will get 2 pi rad per minute. Okay, so which one it would be? This will be the correct answer. Now, what about the third one? Actually, there is a mistake in the question. They are asking like the direction. Okay, look at from the option they are demanding not about the like angular velocity, the direction of angular velocity. Okay, direction of angular velocity, not rad per. What is the toy's direction of the angular velocity? Okay, it's direction. Now, direction of the angular velocity. See, it's clearly mentioned it is rotating counterclockwise. Okay, if it is rotating counterclockwise, we know counterclockwise will be positive. Okay, so we have two options for positive. Positive because it is slowing down. Nowhere it is mentioned whether it is slowing down or speeding up. Okay, so this is wrong. And second option, positive because it's turned counterclockwise. So which can be the correct option? It is mentioned counterclockwise, and you know that like counterclockwise rotation will be considered as positive. Okay, now let us go to the next slide. Okay. These are some question which came before. Look at, see, I don't know whether it is clear. This value is 5 meter per second. Okay, 5 meter per second. It's written over here, and the radius is 25 centimeter. Okay, now look at, a belt passes over a wheel of radius 25 centimeter. So radius they have given 25 centimeter. Okay, and if a point on the belt speeds 5 meter per second. Okay, 5 meter per second. Meter per second always it's V. Okay, so V is given 5 meter per second. So how do you understand it's W or V? W will be mentioned in rad per second. But over here it is mentioned meter per second. So it's a linear velocity, not the angular velocity. Okay. Now what they demand? They demand angular velocity of the belt. So they need to calculate omega. So they have given two quantity, one is R and V, and you need to calculate W. See which equation are we? Even though it's mentioned 3, it's not connected with the 3, it's, I think it's 4. Okay, so which equation will be connected? Look at V, R and W. So which is V, R and W connected? So this is the equation, V, R and W connected. Okay, so what is the relation? V, that is equal to R omega. Okay, now like you can substitute the value 5 into radius is given. See, this is given in meter per second, one is given in meter per second, another one is given in centimeter. So in this situation, what is to be done? Like you need to convert both in the same unit. Like this you can convert into 25, that has to be converted into meter. So how do? You will divide this with 100, so that you will be getting 0.25. So suppose if they give both of them are in centimeter, you can directly do, no need of any conversion. Okay, same unit they have given, then you can directly substitute it and do. But over here one is in centimeter and the one is meter, then you should convert it. Okay, so 5 meter per second will be equal to 0.25 multiplied by omega. Omega you put x and shift and so on. Okay, otherwise we just divide this with 0.25 and this also with 0.25. So which one will be the correct answer? It will be 20 rad. Okay, 20 rad per second. But the problem, look at the option, we have two 20 rad per second, this and this. Out of this, which one will be correct? Okay, so to understand, they have specified the direction of the angular velocity as well. So like how do you understand whether it is come out or come in? Okay, so for that you have your right hand, you have to hold your forefinger in the direction of like rotation. Direction of rotation, you know that it is coming to the left, so you will hold the forefinger in the left. Look at in which direction the thumb is pointing. Thumb is pointing to you, right? So which means it is coming out. So which option will be correct? See, this one will be the correct option. Okay, now let us look at the next question. The angular velocity is a vector quantity. Which of the following correct about the direction? I think this we have addressed when we talk about the angular velocity. Okay, if this is the rotation, a circle, the angular velocity always will be perpendicular to the plane of rotation. Okay, if it is rotating on the ground, like the angular velocity will be perpendicular to the ground. That's the idea. Now look at, so angular along the axis of rotation. See, along the axis of rotation, that is wrong. Okay, perpendicular to the axis of rotation and parallel to the radius of rotation and a tangent to the circular path. So this is wrong and this is wrong. Perpendicular to the axis of rotation, perpendicular to the axis of rotation, along the axis of rotation, I think, yeah, this should be the correct. It's perpendicular to the axis. See, when we are specifying along the axis of rotation, see, the direction will be like along the axis of rotation, along the axis of rotation, perpendicular to the axis of rotation. Look at, see, if this is the axis of rotation, okay, if this is the axis of rotation, perpendicular to the axis of rotation means this one. So this is wrong actually. Okay, so which could be the correct answer? Like this will be the correct answer along with the axis of rotation, and this is wrong. Perpendicular to the axis of rotation is wrong. Okay, along with the axis of rotation, that is the correct answer. Fine. Now let us go to the next one, and see, the next question is connected to the V, omega and R. So the relation we know, P, that is equal to R omega. Okay, or even when you read you will understand that. This is one of the complex question and which is mentioned in the textbook and which is mentioned in the high class book. Okay, question number 10. Now a CD-ROM has a spiral track beginning 2.7 centimeter from the center, end at 5.5 from the center. The disk drive keep a linear velocity 1.5 meter per second, while the disk play from for 76 minutes. Okay, what are the angular velocity? You need to calculate angular velocity at the start and end of the track. Okay, and angular acceleration. So all the three quantities you need to calculate: angular velocity, initial angular velocity, final angular velocity, and alpha. Okay, these three quantities you need to calculate. So let us connect with the equation as well as let us connect with the concept a bit. See, for your understanding, let me draw. Okay, so suppose this is a CD-ROM. You might have seen the CD. Okay, CD-ROM, like here we will be having a spiral track. Everywhere we will be having a spiral track. There the data will be recorded, and when you put it in the CD player, like this will be rotating. So when it's playing, the linear velocity, okay, the linear velocity through which it will be moving, that is clearly mentioned how much it is. V is 1.4. So from starting to stop, what will be the linear velocity will be 1.4 meter per second. There is no change at all. Okay. Now they said from the beginning the radius is how much? The radius is 2.7 centimeter, which means you need to convert that into meter. Okay, so you will divide that with 100. You will get the initial radius Ri. How much it would be? It will be 0.027 meter. Okay, now similarly, like when the CD completely rotated, then it will be reaching at this particular point. The radius they have mentioned how much it will be. It will be 5.5 centimeter. 5.5 centimeter, which means it will be 0.055 meter. Okay, now how do we calculate, or which equation are we supposed to use? They have given only two quantities. One is radius, another one is v. So if radius and v is given, to calculate angular velocity you must use which equation? V is equal to r omega. Okay, previous equation we just addressed it. Now they are asking angular velocity at the start and angular velocity at the stop. So which is the starting point? Starting point, the radius is 0.027. Stopping point, the radius will be 0.055 meter. Okay, so for the start, let me use the equation v. In both case, for the start and stop, v will remain exactly same. V will be is equal to r start into omega start. Okay, so what is v? V is 1.4. That will be equal to, what is radius start? Radius start is 0.027 into, you put it x. Okay, so you will get 1.4 divided by 0.027. That will be your omega start. So what is omega start? Omega start, you will be getting 52 rad per second. Okay, you just divide 1.4 divided by 0.2027. okay, it's 51.8. it's approximately 52. Okay, now look at, we have two options, this and this, so we can consider either A or D will be the correct answer. Okay, now let us calculate the final velocity as well. What is the final velocity? Final velocity, like final angular velocity, v, that is equal to r final into omega final. So v will not change, it's 1.4, and r will become what? R will become 0.055 into x. Okay, shift and solve, you will get 1.4 divided by 0.055. So it is 25.4. Let us consider it as 25. Okay, so over here omega final you will get it as 25. Okay, so look at A and B will have 25 and this also 25. So again, so you cannot select A or D. So to get the final answer, what is to be done? You need to calculate alpha as well. So how do you calculate alpha? You have omega initial, you have omega final, and you have time taken as well. What is the time taken? Time taken will be 76 minutes. 76 minutes. Always you do remember that, like the acceleration will be counted in seconds. So this you need to convert into seconds. So how do you convert minute into second? You need to multiply this with 70. Okay. So first of all, let us convert the time into seconds. So 76 into 60. 76 into 60, how much it will be? It will be 4,000 560. Okay, second. This much will be the second. Now, how do you calculate alpha? Alpha, let me calculate it over here. And what is the equation? See, turn or search the equation for alpha. Alpha. This is the equation for alpha. Time omega. See, they are connected with the time and omega. So this is the equation you will be selecting. Alpha will be equal to delta W. What is delta W? Delta W divided by delta T. Okay. So how do you calculate delta W? It's W final minus W initial whole divided by T. Okay. We have final velocity and we have initial velocity. Final velocity is 25. Okay. Initial velocity is 52. Okay. And time taken is 4560. Okay, so what will be the correct answer? It will be 52 minus 25, 25 minus 52 minus 27 divided by 4560. Okay, so finally the answer will be 0.0059. 0.0059 will be approximately equal to 0.006. So which one it will be the correct answer? See, this will be the correct answer. So A will be the correct answer for this. Okay. Now, like I think the question is too lengthy, but discover question number 4 as well as question number 5. Okay, it's an important question. Now look at the next question. I think it's a small question. A wind turbine blade tip is 22-meter long. Okay, so here you can see this is a wind turbine. It is 22-meter long. I'll use another color to avoid the confusion. So the wind turbine, like it is 22-meter long, means that is radius from the center. The blade tips move at a speed. See, the tip is moving at a speed of like 44 meter per second. So 44 meter per second, what is this quantity? This quantity, you should understand its linear velocity. This quantity is radius and they are asking angular velocity. R, V and W has to be connected, which will be, again this will be the equation. It's V is equal to R omega. Okay, and finally what we will get, like we will be getting, what is the value of V? V is 44. Okay, and radius is 22. Okay, and omega, you just divide this with the 22 and 22, and finally you will get a correct answer. So which one it will be? I think 2 rad per second. So which will be, this will be, C will be the correct answer. Similarly, there is another question in connection with the CD-ROM. A CD-ROM rotates so that the point of track at a radius of 0.05, the radius is given 0.05. Okay, and the linear velocity is 1.2, angular velocity, I think it's a repeated question, you try to calculate it. Okay, it's easy. Now let us go to the next question and next slide. This is same kind of repeated question, I believe. Okay, And the first question I'll just read. If it is repeating, we will not be will not do. Okay, a ceiling blade tips. Okay, a ceiling fan blade tip is given. Okay, you know a ceiling fan will be look like this. Okay, its blade tips at a radius of like 0.45. So understand this is radius. Okay, and fan rotated rad per second. What is rad per second? It's omega. And then they are asking the linear speed. What is linear speed? V. So you need to connect V, that is equal to r omega. Radius is given and omega is also given. So you just multiply it and find out the answer. It's easy. I'm not doing the calculation anymore. Okay, it's easy, direct calculation. Now, second question. A Ferris wheel has a radius. Read. This is the Ferris wheel. Like its radius is given and linear velocity they have given. They are asking angular velocity. I think this is also an easy question. Try to do and you can find out the answer. Now, next one, a car tire has a radius of 0.32 meter. A point on the rim moves with a linear velocity. Linear velocity and radius is given. Again, they are asking for angular velocity. This is also easy. You try to do it. Okay. Now, I think this question we will do. Okay. A washing machine drum rotate 635 revolution per minute. Okay, it's rotate 635 revolution per minute. What is this quantity? This is the frequency in minute. Revolution per minute or revolution per second is frequency, but basically frequency will be counted in minute. So try to understand, this has to be converted into second. Revolution per second you need to convert. How do you do? And moreover, you need to understand whenever they give a revolution per minute or second, it's in connection with the frequency. So frequency will be 635 revolution per minute. Okay, it's in minute. So you need to convert this into second. So it will be 635 in 1 minute. How many seconds will be there? It will be 60. Just divide with the 60 so that you will get the frequency in second. Okay, so 635 divided by 60. So how much it will be? It will be 10.5 or 10.6. 10.58 is coming. So let me take it as it is 10.6 hertz. Okay, revolution per second is hertz. Okay, or you can write revolution per second. Okay, spinning. Okay, so initially it is spinning at this particular speed. Okay, when the lid is open, the motor turn off and drum slow down to stop after 8 seconds. Understand it clearly. So it is coming to stop. So what will be the velocity when it is stopping? Velocity when it is stopping, you can say omega final they have given, it is 0. It is coming to stop. And how much time it took? It's 8 seconds. So what they're asking for the angular acceleration. This is connected with not this question, this is connected with the next question actually, like question number 5th. Okay, so question number 5th, we know it is alpha. Angular acceleration it is delta w divided by delta t. So what is delta w? Delta w is omega final minus omega initial divided by t. Okay, so omega final we have given, they have given the omega final. How much it is? 0. But omega initial did they give? Okay, so they have not given omega initial directly, but they have given frequency. If they have given frequency, how do you calculate omega? Omega and frequency is connected with 2 pi f. Okay, so f is given. How much? It will be 2 into pi into 10.6. Okay, so you can get the value. It will be how much? It will be 2 into 10.6 into 3.14 will become 66.6. Okay, rad per second. So omega initial they have given 66.6 rad per second. Again, understand it clearly. They have given in revolution per minute and they converted into revolution per second, that is frequency. From there we calculated omega initial. Okay, and omega final we took it as 0. Why? Because it comes to stop. Okay, Now, what will be the angular acceleration they are asking for? Okay, omega initially you will put it as 66.6 whole divided by, what is the time taken? It's 8. Okay, so just divide this quantity with 8. So what will get? You will get minus 8.3. So which will be the correct answer? This will be the correct answer. See, actually, question before and question 3 we almost completed. I think we can go ahead with the next few questions. So, see, these are certain questions which is the connected with the conceptual. There is no much calculations and all. Okay, look at. This is connected with the not only first question. This is connected. Not only the fourth question. It is connected with the first, second, and third and fourth. Okay, all the four questions it has been connected. Fine. Now, like a rotating disk turned through an angular displacement of 2 radian. Okay, it's rotated an angle. Okay, a port A. So this particular disk is rotating an angle of 2 radian. You know, 2 radian will be approximately how much? 2 radian will be equal to around 1 radian is 57 to 2 radian is around less than 120 50, okay, 115, okay, approximately whatever it is. Now a port A is placed at a distance, so this is port A, okay, closer, and port B is placed at a distance of 1 meter, okay, this is far away. Now which statement is correct about this motion? Both ports move through a same angular displacement. See, if it is rotating, if this is rotating 120 degree and this must rotate how much? 120 degrees. So the first statement I believe it is clear. Both port moves through the same angular displacement, but port A travel a greater linear distance. Port A, this is port A. Port A, see which is closer. As we learned before, which is closer will cover less distance. So this option is wrong. Okay. Port A travel less a greater linear distance. So this is wrong. Now, second option, look at both ports move through a same angular displacement. This is correct. Okay, and but port B travel greater angular. Port B is farther away. This is farther away. So obviously, which is farther away, that will cover more distance. Okay, so which will be the correct answer? This one. Similarly, the same option will be addressed over here. Look at the angle rotated by the first port and second port is exactly same, so this is correct, but the linear distance covered, S stands for distance. Okay, S1 is smaller than S2. Okay, S1 is smaller than S2, of course. S1 cover less distance and S2 cover more distance. So sometimes they can give, instead of writing, they can give the option like this as well. Okay, this is correct. Okay, now let us go to the next question. Two ports are, it's also connected with the same figure. Two ports are placed, exactly the same question. Which statement is connected about their angular velocity? See, think of it. If they cover the same angle, their angular velocity will be same. Okay, because both the port is rotating sitting on the same table and they take same time and they rotate same angle, so their angular velocity will be same. So which will be the correct option? Which statement correct about the angular velocities? So omega 1 and omega 2. Okay, now the same like a question which included the linear velocities as well. See, linear velocity and linear distance is connected, and angular velocity and angular displacement is also connected. Okay, so two ports are placed at the same, this is same, I'm not repeating the question. Choose the correct option. So which one will be? Omega 1 and omega 2 must be equal, and the linear velocity which is closer should be lesser, and another one will be farther. So look at, see, this is correct, and omega velocity, linear velocity of the first port is smaller and the linear velocity of the second port is bigger. So which one will be? This will be the correct answer. Okay, now these are the explanations in connection with. If you want, you can read. Now let us go to the next question. See, this is also the same concept which is connected with two students are rotating or running around a circular track. Okay, running around a two circular track. One runs on a track with a larger radius. So this person is rotating with a larger radius. R is radius, R is more. The other one track with a smaller radius. So this one is a smaller track. Both complete one revolution in same time. They took to cover this like entire rotation the same time. If this take 5 minutes and this also took 5 minutes. Okay, so both person take same time for the same angular displacement. So they completed one rotation 2 pi in the same time. Okay, that's what you need to understand. Now, how do their angular velocity and linear velocity will be compared? Okay, you know that how do you calculate the angular velocity? Angular velocity omega will be equal to 2 pi divided by 5. Here also angular velocity will be calculated with the 2 pi divided by 5. Okay, I have just taken a number. See, if they cover the same angle with the same time, angular displacement will be, angular velocity will be same. Okay, so both the person is having the same angular velocity. Now, see, the one is the boy is running with a bigger track. Obviously, like he has to be faster to complete one revolution with the same time. Okay, so which option could be? They have the same angular velocity, but the student on the larger track has a greater linear velocity. Obviously, the larger track must have the greater linear velocity, then only he will be able to cover. Okay, so this will be the correct answer. Now, like this questions you can do it. Okay, yeah, it's easy. Okay, but the problem over here, like you need to just identify the correct equation. So try to do that. Fine. Now, this is again connected with our fifth question, angular acceleration. Let us read the question. An electric drill is rotated counterclockwise at speed up from 20 rad per second to 140 rad per second. So what is this? 20 rad per second. From 20 rad per second means omega I, and 2 rad per second means omega f. How much time it will take? 3 seconds. Okay, so like what they are asking, angular acceleration we know. See, you can look at the calculation. 140 final angular velocity minus initial angular velocity divided by time, you will be getting 40. And moreover, you should identify whether it is positive or negative. You should understand that like it will be counterclockwise will become positive. So which will be the correct answer? Positive 40 counterclockwise. Okay, so this will be. Similarly, you have one more question over there. Okay, try to do it. It's in connection with the ceiling fan. A ceiling fan rotated a ceiling fan is rotated clockwise. Okay, after being switched off, it's slowed down. See, from 18 rad per second to 6 rad per second in 4 seconds. So the calculation of alpha, it's easy. You'll be getting minus 3 rad per second. Okay, and this is the contradictory part. If it is slowing down, see which option you will be selecting. It is rotating like a clockwise only, but there is a negative which indicate the direction will be exactly opposite, counterclockwise. Okay, so negative indicate it will be counterclockwise. It is slowing down. Just because of that, we will have which option? We will be having minus 3 counterclockwise. Even though it is rotating clockwise, it is slowing down, so it will be considered as like it is the acceleration will be having like in the opposite. Okay, so minus 3 counterclockwise will be considered the correct answer. Okay, now I think we almost completed every questions in connection with this particular chapter. Okay, we will be this is another question which came before. Like I think you can calculate a centrifuge just like a washing machine, accelerate for 30 seconds. So time is given. From rest mean omega I they have given it as 0 to 2000 rpm. What is rpm? Rpm means rotation per minute. Okay, rotation per minute. So what is rotation per minute? Before we did this particular situation, rotation per minute is frequency. So if they have given frequency, first and foremost, what is to be done? This you need to convert into rotation per second. So what do you do? 20,000 rotation per minute. To convert 20,000 rotation per second, like how do you do? This minute you will be converting into second. So like it will be 2000 divided by 6. What is 2000 divided by 6? Will be equal to 333. Okay, 333.3 hertz. So rotation per minute you should convert into rotation per second. Okay, why you need to calculate this? This is your frequency. What they're actually asking for, it's angular acceleration. So what is angular acceleration? Angular acceleration alpha will be equal to omega final minus omega initial divided by t. Okay, so time they have clearly mentioned is 30 seconds. So omega final, we know, like it's speeding up, right? Starting from 0 and it's speeding up. Like to find the omega final, we have frequency. Omega final will be what? Omega final will be equal to 2 pi into frequency. So it will be 2 into 3.14 multiplied by 333.3. Okay, so substitute the value, it will become 2 into 3.1 pi will be 3.14 into 3.3 minus 0 4 divided by 30. Okay, into 3.14 whole divided by 30 will become 69.7. 69.7 is approximately equal to 70. What is the unit? Rad per second square. So this will be the correct answer. Fine. Now let us move to these are certain questions which is connected with this. Okay, I'm not doing the calculation question. Okay, the rotation per minute that you need to convert. These are the practice question you can do. Now I'm focusing only on the last question. Okay, two gear. Okay, in car we will be having gear. The gear like will be connected with the one over the other. Okay, this is how it will be look like. Now a greater larger A is a larger and gear A is larger and gear B is smaller. Okay, which statement correctly compare the angular velocity and the linear velocity of the teeth in contact? See, before going ahead with, try to understand this is in contact, which means if this move, this also will move the same distance. The linear velocity for both will be, as they contacted with each other, the linear velocity V for both of them will be exactly same. So V for A and V for B will be exactly same. Then what will be their angular velocity? This is the equation which is to be connected. V is equal to R omega. Okay, if V is constant, R and W is opposite to each other, which means if radius is more, omega must be less, means angular velocity must be less. I'm repeating, this concept is very much needed. We studied about the other quantity, like when the omega is constant, how the radius and velocity is related with each other. If radius is more, velocity must be more. This is another concept where the linear velocity will be constant or linear velocity will be equal, but what will be the relation between radius and omega? They are inversely proportional. One increase, another must decrease. So let us choose the correct option. See, gear A has a greater angular velocity and both gear have a different linear velocity. Okay, different linear velocity, obviously this is wrong, and moreover greater angular velocity. See, gear A is having greater radius will have less angular velocity. So first option is wrong. Now what about the second one? Gear B has a greater angular velocity. Possibilities are there. Look at gear B is radius is less. Obviously angular velocity must be more. Okay, and both the both gear have the same linear velocity. So which option will be correct? This will be the correct. Okay, then third one I am not reading. Like try to understand. B will be the correct answer. Why? As they contacted, the movement at the edge, linearly, they will be exactly same distance, they will move at the same time. Okay, linear velocity will be same, but their angular velocity will be different. One with a larger radius will have less angular velocity, one with a smaller radius will have more angular velocity. Okay, so this is it. This is in connection with the fourth question, but like you should remember.